Okay, welcome everyone. Today, we're here to do a short course on an introduction to commercial and multifamily energy audits. This is being presented to you today by Bauman Consulting with support from DCSU in terms of their ongoing continuing education program and with support for that project through the DC Department of Energy and Environment. So we'd like to thank them for organizing and hosting this event. And we have quite a bit to cover, so we want to move forward with getting into our presentation and helping walk you guys through an introduction to energy audits. So I want to start off by introducing our panelists. We have first Oliver Bauman, who's the founder and president of Bauman Consulting. Oliver has quite a number of years, over 25 years of experience in the building commissioning, measurement verification, high performance building business in DC. And after he spent 10 years working in Germany, he moved to DC and founded Bauman Consulting in 2006 and has helped a lot of the market and the industry work on bringing high performance buildings to be the norm in the industry as opposed to the exception. Oliver has a master's of science in mechanical engineering from the Technical University of Munich, which he earned in 1997. Next up is me, Scott Emery. I'm the Senior Vice President and head of the Washington, D.C. office for Bauman Consulting. I'm a mechanical engineer with well over 25 years of experience in a varied range of fields, but have spent most of the last 20 related to the built environment doing energy efficiency consulting. I'm a licensed engineer in Virginia, Maryland, and D.C. And finally, we have Adam Herzer, who you can see has a long list of credentials, but has quite a bit of experience in building commissioning. She's a certified energy manager and energy related fields for the built environment. And so Adam's got deep experience with energy auditing and building performance, and so he'll be sharing that with us today as well. So for our agenda, very quickly, what we want to cover. First, we're going to talk about BEPS requirements for energy audits, and that just gives us a little bit of framing that I think is important to understand, why energy audits are so critical and what's happening with BEPS. This isn't a BEPS webinar, but we want to at least give you that framework and context in terms of energy audits. We'll then move into talking about what an energy audit is and why you want to do one. From there, we'll get a little bit deeper with some energy audit examples, looking at kind of some high-level overviews of some results from commercial, multifamily, and also looking at water audits, because that's an important part of sustainability in our built environment. And then we'll dig into some energy efficiency measures, some specific examples of a few measures where you can kind of see how actually calculations work and how ultimately different things might interact with each other. And then we'll have a little bit of a recap and talk about how to learn more, and we'll also give a chance for Q&A. And so on the Q&A, if you have questions, please add your questions to that Q&A button. You see the one with the two little like cartoon balloons. If you can put your questions there, that would be great. And then next, or just last thing I want to say is by the end of the day, hopefully you're going to end up with a basic understanding of energy audits and the procedures of energy audits and get a little bit of hand-on experience so you get a feel for what's involved with an energy audit. So we have a poll question. I want to go ahead and pop that up. We want to find out who we're talking with today. So I'm going to launch our first poll, which is asking about what your background is. If you're in the field of, say, providing services or materials to buildings, that would be item C, so contractors, product vendors, service providers. If you don't see your category up there, please feel free to go ahead and click on other, but hopefully we have a category that'll fit where you fall into this list. And we'll let that poll stay up there for a few more minutes or a few more seconds, and then we'll kind of share that with everybody to see who we have on the poll today. All right, I think we've got most everybody has replied, so we're going to end the poll and we'll share those results to see what we see today. I can't see, Mark, is that being shared? I think it is. So we have looks like we've got a number of energy auditors on the call. Our next biggest group are contractors and vendors, some building managers, facility engineers, and then a pretty good chunk of others. So looks like we got a good mix today. Hopefully this will be useful for all of you as we work through this process and talk about energy auditing. Okay, so the next thing I want to talk about really briefly is BEPS. So BEPS is the Building Energy Performance Standard. The first set of Building Energy Performance Standards were issued January 1, 2021. And so we're in the first BEPS cycle. You see here, we have this item marked as BEPS 1. And this is the section we're in. So BEPS 1 is going to run us up through 2027, and then there'll be another round of BEPS starting in 2027. So the standards get reset every 6 years. And so one thing it's important to understand is this is an ongoing process to drive improvement across the industry. It's not just a one and done situation. So today we're working on BEPS Cycle 1, which covers privately owned buildings over 50,000 square feet and DC owned buildings over 10,000 square feet. And since we're talking about multifamily and office buildings today, or commercial, mainly office, I mean, there's other buildings to cover, but we're gonna talk about office and multifamily here. So if you have an office building, you need to have an Energy Star score of 71 to meet the BEPS standard. And if you have multifamily, it's a 66. And so what we know from this is that if you have a building that falls below that for the current cycle, then you need to do something to improve your energy performance to be considered compliant. And so there are 4 compliance pathways that you need to be aware of. We won't go into deep detail, but just at a high level, the first pathway is called the performance pathway. And that says if you lower your building's energy use by 20%, essentially by 2026 at this point, then you would end up being considered compliant with BEPS and meet the requirements of the policy. If on the other hand, you say have a score that's already close to the target, either that's 66 or that's 71, if you actually get to that target by 2026, so if you have a building with, say, a multifamily with a 60, if it gets up to a 66, that would be another way that you can potentially comply with BEPS. And then the third option is what's called the prescriptive pathway. So whereas the first 2 are going to be based on how you perform and measuring it, the prescriptive pathway is going to be based on whether you meet a list of activities and actions. And this is going to be tailored to each building. I kind of talk about it. Each building will have its own prescription, and each building will have to do a certain agreed to list of things in order to comply. However, regardless of how that building performs, if you do everything on the prescriptive pathway, you're considered compliant. And then there's some alternative compliance pathways. And I'm not going to get into those right now. But one thing that's important to understand is that part of the policy is if you don't meet the BEPS requirements or meet one of these guidelines, you potentially face significant penalties, which would be up to $10 a square foot. So it's important to follow through and comply. So let's talk briefly about if you go with the prescriptive pathway, and this is where we start seeing an energy audit explicitly coming into the picture. Now, you probably want to do an energy audit for either the performance or the standard target pathway. However, for the prescriptive, it's a prerequisite or a requirement. And so you must do an ASHRAE Level 2 energy audit and have that ready by April 1, 2023. Now, for all buildings by April 1, 2023, they need to establish what pathway they're going to pursue. And so there's very specific requirements for this ASHRAE Level 2 energy audit in BEPS that must be met under the prescriptive pathway. And here's some details. I'm not going to go into that in the interest of time. We can come back to that. You'll get copies of the slide, but it must meet certain criteria, and you must have an ability to get a package of measures that has a certain amount of energy savings projected for that to be considered an acceptable energy audit. Now, another important thing to know is the policy requires that you have one of these energy auditor certifications. So if you're new to this and you're looking at how do I get into this field, you want to look at these certifications, which are Certified Energy Auditor, Certified Energy Manager, Building Energy Assessment Professional, High Performance Building Design Professional, or Multifamily Building Analyst. One of these criteria, you have to have those credentials to be the person who is officially providing that energy audit. And finally, the last item here is there's a portal that DOEE has established, and we'll share that later through other means, follow-up materials, that you actually have to submit energy audit information through that portal, which you can find at this BEPS energy audit template. So with that, I know that was a quick overview of BEPS, but I just want to make sure you understand how BEPS is driving things. And with that, I want to hand it over to Adam and let Adam talk us through what is an energy audit.
All right, so 90% of our electricity is consumed by our buildings, and 60% of the carbon emissions come from our buildings as well. So why do we do this? to meet the 2020 challenge that we have, architects have set up these challenges to get to 50% emissions by 2020 and all the way to zero emissions by 2030. So anyways, the next one. And another alternative is to meet our ESG items. So here you can see so we're going to meet renewable fuels, reduce our greenhouse gases, and water management. Also, there's the BEPS that Scott previously talked about, and then there's the New York City has a local 97 code. So here's just a Wikipedia on what an energy audit is. An energy audit is an inspection, survey, and analysis of energy flows for energy conservation in a building. It may include the process of the system to reduce the amount of energy input into the system without negatively affecting the output. And a commercial and industrial real estate and energy audit is the first step in identifying opportunities to reduce energy expense and or carbon footprint. And today we use the standard ASHRAE 211 that was published in 2018. So audit reasons for BEPS compliance. Also, in many jurisdictions require energy audits in interval basis. New York City and San Francisco do that. LEED EBOM recertification has an option for energy audits or retrocommissioning. Many clients with energy efficiency and green standards need help getting there. Low energy audit or low energy star scores also would be a reason. And also to save energy, to save money, and to reduce the greenhouse gases. So let's talk about the three types. There's a level one. And a level one, you're doing a preliminary review and you're using historic basis to do it. And facility site survey and space function analysis. So you're going in and walking the building and seeing what actually is in the building and use that analysis to measure to what is in your Energy Star score already. And then you're also identifying low and no cost energy efficiency measures. And then in that, you're giving it a either high, medium, or low level in the final report. A level two is energy cost component breakdown. Facility and site survey, O&M procedures, key operating parameters, energy use breakdown, energy efficiency measures with economic analysis with simple payback and return on investment. And a level three brings them all together. Determine the recommended EEM, a schematic diagram, a measurement of the operating model, energy model, a cost and cost savings, life cycle cost analysis, and risk assessment, and sensitivity analysis. So here's key measures to get to a successful audit. You collect 15 months of utility data and evaluate that data month by month. Collect design data to compare with that energy data. While conducting a site survey, you focus on the following: low-hanging fruit and design improvements. You start your energy conservation measure savings and calculations. You calculate the cost of the implementation using either engineering estimates or get a quote from the trusted vendor. Even internet searches are good. You create an executive summary with prevailing list of what you believe is most to least important, simple payback, savings, and low cost. Implementation may influence your priority list. Last, use comparison metrics for how well the building is currently performs and how well it will do in EEMs, ECMs are completed. Kilo BTUs per square foot, and so on and so forth. It helps them in the metrics. So with ASHRAE 211, you have free forms. There is a link right here on the top. They'll give you the free forms that you can use to anybody. Basically, when you open up the form, it's an Excel file, and the first tab gives you instructions on what tabs to use and for what level of audit you use it. And you just follow the tabs going through each one of them. Here's a line showing you go one by one through the tabs, following the instructions to complete the full normal form. So in a final report, you'll get this. You'll get an overall view of the building, followed by a table of contents, followed by a summary where you go through everything, identify what the building is currently operating, what the components are and how they are operating, how well they are operating, and so on and so forth. Then you have inside your executive summary, you have an EEM table, and you give and you identify how the process is, or how well your return on investment and so on and so forth is. And then at the end, you have a breakdown of where your energy is consuming.
All right, thanks, Adam. We'll move on now to start talking about some examples of energy audits. Went the wrong way. Sorry about that. So Oliver, I think we're handing over to you to start pick us up on our more details, more drilling in more details there.
Okay, thank you, Scott. So I will use a couple different case studies, projects that we've been working on recently to show just examples how the process works. So Adam mentioned at the beginning, we do our preliminary energy use analysis, PUA, according to ASHRAE Standard 211. And that's what you see here. So we just, this is a project in Washington, D.C., a multifamily building, 262,000 square feet. And the source energy use intensity of that building is about 260 kilo BTU per square foot per year. And the building has, believe it or not, an Energy Star score of 1. So first thing is, once we saw the utility data and the Energy Star score, we validated that the data is right. It was right. We looked at the different targets that you see. Scott mentioned earlier, we have the 20% reduction to meet BEPS compliance if the building does not meet the BEPS standard right now, which you might remember was 66 for multifamily buildings. So one option is to reduce the energy consumption by 20%. So you see that red dot here, or the BEPS median is shown as another black line. So this is where you would need to be with that building in order to comply with BEPS. And what we see here, even if we get a 20% reduction, we would certainly not comply with any future BEPS cycles. So that's why we already talked about BEPS 1 and BEPS 2 targets here in that chart. So this is kind of setting the goals and discussing the overall energy efficiency goals that we want to achieve with the client. And it is very important at that point, at the very beginning of your energy audit, to really sit together with your client and discuss what are the goals in this case. When we talk to the building owner, they even brought up What about getting to net zero? What would we need to do to get all the way down to become a carbon-free building? So in the next step, we verified that the data. This is a screenshot from the Energy Star portfolio manager. So all buildings in Washington, D.C., certain size up, need to benchmark the data in building in the portfolio energy manager. And what we do here is we just look at historic data, what's in there for 2020, 2019. Are there significant differences? Did anything change? Can we use that data to actually validate that the data entries are correct? And you see that the relative change from between those 2 years is somewhere between 1.5% to 4%, depending on what metric you're looking at. So this is a pretty stable benchmark, and we can use that as a validation that the data is accurate and correct. You can also go many years back and see a trend. Ideally, you identify if there were any energy efficiency upgrades or retrofits to the building in previous years that should be reflected in those metrics. On the next slide, so you heard me talk about site energy use intensity, EUI, and also source energy. And both metrics are important, and it's really important to understand the difference and what it is, because you will be talking about both metrics throughout an energy audit with your client and building owners. So site energy is the energy that is metered at your building. That is the energy that is delivered to your site and metered. That's what you typically see on your utility bill. That is either electricity, that could be natural gas, it could be steam, or it could be oil or wood pellets, whatever energy you use on site to generate or to use in your building. The source energy goes all the way back to how the energy is generated. So it includes the efficiency of the generation, and it includes the losses for the distribution. In the example of electricity, so your site energy would be the kilowatt hour electricity that you meter. The source energy is the energy that goes into generating that kilowatt hour of electricity. And since we still have a lot of power plants, fuel burning power plants in our energy mix, the current source to site energy factor is about in the range of 2.6. That includes that there is renewable energy already in the mix and other energy sources, and that source energy factor will come down further over time. But it is a difference, and the source energy, that is actually relevant when you look at carbon emissions, because your carbon emissions for electricity, they happen on the plant level, and you really need to count what goes in those plants and emits greenhouse gases and everything. So after that, quick sorry, Scott, that sign was not for me, right?
What was that? I'm sorry.
Okay, I thought you gave me a sign, but I don't think
No.
it was. Okay, so here, back to our case study. This is, then we're very early at the energy use analysis. You see two pie charts. The left one is the site energy used by fuel type. So we simply use the 1 year of utility bills and put it in a table and a chart that actually comes from that ASHRAE 211 form that Adam mentioned earlier. And we see that in that building, we have of the overall site energy use, 2/3 is natural gas and 1/3 is electricity. So this is the energy side. When we look at the energy cost side, the picture looks a little bit differently. only 1/3 of the energy cost is actually for natural gas and 2/3 is for electricity. And that is just a result of different energy tariffs, and that natural gas is relatively inexpensive compared to electricity. And that's important to understand for all your economic analysis, and also for the impact of energy efficiency measures where you possibly switch fuel sources. So let's say from natural gas to electricity, because your energy consumption might go down, your system, your building might become more efficient, and but the energy cost might go up, and we actually show an example of that later on. So you have the general understanding what fuel types you use, where you spend your money. The next step is you want to break down that site energy to the different use types. This is a chart where we did that breakdown. So it shows that 60%, 59% of the site energy is used for space heating. 11% is used for space cooling. If you add the energy that's used for distribution of air and water, like the fan energy and the pump energy, you see that more than 80% of the site energy is used to condition the building, heating and cooling plus the distribution. We then have domestic hot water. In that case, pool water is included here as well. We have conveyance, there are elevators in there. We have lighting. We have plug loads. That's all your TVs, your computers, everything that you plug in your building. And the site energy use breakdown looks a little bit differently between a multifamily residential building versus a commercial building, let's say an office building, where you have typically more plug loads for computer, printers, and everything. On the residential side, your heating and cooling is typically a little bit higher. We can tell quickly back, Scott, sorry. We can tell from that pie chart and the distribution. Once you've done a number of energy audits, you know what a typical distribution should look like, and you can also use that as a sanity check for these results. Space heating in this building is higher than usual, but it does reflect the building characteristic, where we have single pane windows, we have large window areas, we have not well insulated walls. It's a building from the 1970s, I believe. And we also found, when we did that initial walkthrough during the level 1 energy audit, that there's a lot of leakage. We saw individual space heaters in apartments, so it's an indication that the building envelope is not efficient, and also that contributes to the thermal discomfort that the tenants experience in that building. So there's a lot of opportunity. Another step of the energy analysis, next slide please, is since we have monthly data, what we typically do is we sort the data and plot it over the monthly average outdoor air temperature. That's what we've done here. In that case, we use 3 years of data. We had that data, utility bills and utility data for the last 3 years. I would say the more data you have, the better it is, because it gives you a better picture of the history of your building. And so the green dots is the natural gas consumption monthly, again plotted over the monthly average outdoor air temperature. And what we see here is exactly what we would expect, that with lower outdoor air temperatures, that is to the left, the monthly energy consumption and monthly natural gas consumption goes up because we have more heating demand. And as the temperatures rise, we have warmer months, 60, 70, 80 degrees monthly average, the natural gas consumption goes down because the heating demand goes down. However, what we would like to see in a very efficient building is that natural gas consumption goes almost down to 0, except for that natural gas that you might need for domestic hot water and cooking or other uses that you identified earlier in your energy use breakdown. Here we see two things. First of all, that the natural gas consumption does not go down to zero and actually plateaus here in months where we would expect no heating demand. So there must be other energy use for natural gas that might indicate inefficiency and an opportunity for energy efficiency measures. And we also see that the slope of the energy use in colder months is steeper that we would like to see. A well-insulated building has a much lower slope where the effect or the impact of the temperature difference between indoor and outdoor is less significant. So that's also an indicator and a confirmation that the building envelope is not very efficient and has opportunity for improvements. The gray dots is the electricity consumption, again, monthly over the outdoor air temperature. We don't see much impact of the outdoor air temperature here, but we do see that in warmer months, 70, 80 degrees temperature, that we have a light increase of the electricity consumption. That is an indication for cooling. Our chiller works with electricity. However, in a well tuned building, I would say I would like to see a more dominant increase, or I should say I would like to see a lower baseline of the energy use, the electricity use. So we see that this is almost flat across the year. Also over the 3 years, there is not much change. Again, an indication that there is a lot of opportunity for energy efficiency. Next slide, please. So this is an example from another project where we did energy audits for a portfolio of 20 commercial academic buildings in Washington, D.C. So you see the gross floor area is everywhere from 50,000 to 250,000, 300,000. One building has 500,000 square feet. So it's a good mix of different types of buildings. Their year build goes back to really old buildings from the 1960s. We have two buildings here from the 1920s and 1930s, and then we have also buildings in there that are fairly new. They were built within the last 10 years. We analyzed the site and the source energy use intensity because both metrics, you remember, have an importance. So we want to really understand both of them. We indicated whether those buildings are compliant with BEPS or not. Many of them are not compliant, so they need to do something. And then this is already a fast forward where we indicated, well, the energy costs for that building. So we understand what every building is paying per year for energy, for utilities, and then also the potential energy efficiency measure savings. And you see that's all the way in the range of 30, 40. Some buildings have even 50 and 60% energy savings potential. So there's a lot of energy savings included here. And then also the cost of the energy efficiency measures. But we go a little bit deeper now into another table from the ASHRAE Standard that shows how we actually put those energy efficiency measures together. I want to show a few examples here first. So we do a more thorough energy walkthrough as part of the level 2 and subsequent to the level 1 energy audit. So we go back in the building and then really look at what's going on here. So here just a few examples. We could show hundreds of them here. When you top left beginning see a cooling tower in really poor conditions like that, and that is a clear indicator that something needs to happen with that cooling tower. First of all, it's probably not operating properly anymore. It needs to be replaced or upgraded or at least cleaned And that is also something that you need to include in your building your energy efficiency measures. Then what we see in a lot of buildings is unclear or even conflicting room temperature controls. Like here, you have 4 different devices, all of them kind of controlling the same space with temperature and humidity, but with different systems, so they work against each other. That cannot be energy efficient. And the next picture, air handling units from 1973 that were probably never touched since then, cleaned or maintained. So there's a lot of opportunity here. And understanding the condition of these systems is important to come up with the appropriate energy efficiency measure, whether it's just an upgrade, upgrading a fan from a belt driven to a direct driven, or adding a frequency drive to a fan motor. On a system like that, I would probably not even think about such an individual measure. I would think more holistically and say, well, what can we do if we replace that air handling unit? Then if we see the use of space heaters, I mentioned that before, that's a clear indication that there is a thermal comfort problem. Thermal comfort problem is almost always caused by inefficient systems and not well operating systems. So again, that's an indicator that there is an opportunity for energy savings. The first one is, well, unplug those space heaters and find the cause why the people that work or live in that space think they need a space heater or a fan or something. Then lighting is more and more converted to LEDs, but we still see fluorescent lights and inefficient lights. Even if a building lobby is already upgraded to modern LED, as soon as you go through the door and go to the back of the house, that's where you find those inefficient lights, and often enough they are on 24/7. So they have not, they're inefficient and they have not the proper controls. We have in the next picture single pane windows with aluminum frame, extremely inefficient in that case. That walkthrough was on a nice winter day, and the windows were actually popped open to cool the space down, because at the same time the heat was on full power and there was no real means to control the temperature in that space other than to open the windows to cool the overheated space down with the cold winter air. Unfortunately, no one closed that window, and that was a picture that was taken at the beginning of the lockdown when the pandemic started. So those windows were open for at least several days, if not weeks. And the heat that was provided to that space was just going outside. We see broken actuators, so dampers don't work properly. And then we see leaks and broken systems and corrosion. And of course, what you see here on the top, on the bottom right picture, that system, if it even works, cannot be efficient. So this, you go through your buildings, open eyes, you take pictures, you document everything. Of course, you need to understand what you see, and that determines that helps you to identify those energy efficiency measures. And that's where we go next now. So this is the ASHRAE, a table that is provided by the ASHRAE Standard 211. I walk you quickly through the header here. So you have a measure description. If you click once, Scott, I think there should be a red frame coming up. Yeah. So this is, you start with the description of your measure, then you have your annual energy costs and savings, your energy costs and non-energy cost savings. I get to that in a moment. You have your electricity, the kilowatt hour, your natural gas, your therms. If you have steam or other energy sources, that would show up in this table. And then you indicate the cost of the measure. So you have to actually estimate the cost for the material, for the labor, for permits, for contingencies. You list also, you identify and list potential incentives. So BCSU, for example, is a good source for incentives for certain energy efficiency measure upgrades. You indicate your measure, the life of your measures, a typical lifetime of a system, and you calculate your net measure cost. That's your measure cost less the incentives. And then with that data, you can calculate the simple ROI and the simple payback time in years. And that is the information that ASHRAE requires as part of a level 2 energy audit. And the simple payback year or the simple ROI, that is the information that helps you to convey to your client to make the right decisions, which measures will be done. These are low and no cost measures. That is a not precise science. This is a building where we have $650,000 annual utility bill. So on the total sum on the bottom, you see all measures together cost about $130,000, or after incentives $128,000, and have a simple payback year, payback of 2.6 years. So this is a budget that in that case, in that building, they can manage that almost completely from their ongoing maintenance budgets, and that's why it's defined as a low or no cost measure. And these measures were all recommended. Even you see there's one measure calibrating the thermostat in the residential units that has basically no reasonable payback with 25.8 years. It still makes sense because it improves the thermal comfort tremendously. If you have a thermostat that is off by 2 or 3 or 4 degrees, and we saw that through measurements, it will not control to the right temperature, and the person living in that apartment will constantly adjust the thermostat. It will overheat or overcool, whatever, depending on how the offset is, and we end up with those space heaters and or space coolers in those spaces. So that's definitely a measure that makes sense, even though the simple payback time does not indicate that it's of value. Next slide, and then I'm almost through with my part. This is then the same table where we now go into the capital recommendations. So these are measures that really need capital investment. And so we have the energy auditor. We have to be aware that the recommendations and the analysis that we do here has a significant impact on financial decisions that our clients will make. So we have to be confident, we have to put enough diligence in here to make sure that those recommendations, that the databases is correct, and the recommendations, the conclusions are correct, and also fit within the context of that particular building and ownership structure. So we see one measure, the first one, if you click once, Scott, please, replacing existing air handling units with new high performance units. So we have energy cost savings of $52,000 per year. We indicate what we save in electricity, that's the fan power, what we save in natural gas, that's the avoided energy that goes to the heating coils that comes from a gas boiler, and in that situation we have the measure cost, we have the measure lifetime, we calculate the simple ROI and the simple payback of 6.3 years. Does absolutely make sense to implement that measure because that system has a lifetime of 25 years. So the next 3 measures, that's actually 3 options for the same problem or or the same opportunity that we identified. So we have pool heating, and we investigated 3 different options. We installed a dedicated domestic hot water and pool heating system with a condensing boiler that saves us a certain amount of money. It costs money. It has a simple ROI and a simple payback time of 11 years. And since the client indicated that they want to electrify their buildings and eventually go carbon neutral, we also analyzed direct electric heating for the pool and domestic hot water system. And you see that now that the energy cost savings are negative. So we actually increase the utility costs, and that goes back to the switch from natural gas to electricity. Electricity is more expensive. And we also have relatively low net measure costs with $55,000, but the simple payback does not exist, and also there is no simple ROI. So in the next version, we said, well, what if we install a heat pump system, which uses the electricity in a way more efficient way? So we actually have annual energy cost savings, even though we use more electricity, but not as much more as with direct electric heating, but our net measure cost is more expensive. So we almost need about 4 to 5 times as much investment, and that drives up the simple payback time. But it might still contribute to the overall goal of that building to become carbon neutral. So the point here is it's not always one solution for an energy efficiency measures. You really have to talk to your client, to the building owner, understand what their goal is. It goes back all the way to that preliminary energy use analysis and those initial conversations, and then provide options for their solutions, and then have the client, with your guidance, make the right decisions, what's correct for them. So at that point, I hand over back to Adam, I believe.
Yes. So I'm in energy water, aside from energy audits, water audits help as well. They're often overlooked in the standard energy audit, but they can save a significant amount of time or amount of energy. So the way you do it, you gather information. You obtain the 15 to 12 months of water bills and do an on-site observation, incoming service meter, PRV fixtures, and conditions, followed by determining the flows in and out of the distribution system based on the estimates on the metering. Either test the fixtures with the use of identification data, or look at the color of the aerator and fixture labeled on the gallons per flush. And then you assess where the water losses appear. You use the EPA use rate per person method. Then you analyze data gaps, compare the bills with the calculated consumption, and then you select the appropriate interventions. Create EEMs based on gathered data and calculate the potential savings. Last, you select the EEMs based on desired goals. So here in the upper left, these are 2 ways to look and find what a standard toilet would consume in gallons per flush. Either you open up the toilet lid and look at the under casement, shown here at the dot, or you look at the back of the bowl behind the toilet seat. It usually has a little indication of what the gallons per flush are. So below that, you have the faucet aerators. Most faucets all have aerators, with the exception of water faucets. They do not have aerators. Aerators use a mixture of air and water. It reduces the flow at the same time adding air, and it reduces your consumption overall. So if you pull out the aerators, they come in either quarter sizes or nickel sizes, and there is a direct correlation to the color of it. On the top, there's a ring, so what the gallons per minute are. So on shower heads on the far right, these are harder to identify. Big rainfall ones are not water sense compatible or don't meet water sense criteria. But anyways, these shower heads are harder to find or even identify what the GPM is. So the best way is to test them through EPA bags or a bucket and a stopwatch. So here on the left is a standard kit for a water audit that comes with the bags that help you identify what your flow rates are. And the center is just your standard stopwatch to help you as well. And then on the far right is a toilet flush meter. So even if you have the indicated information on what the toilet is, you might have a problem with the flapper or the toilet is leaking more. So this meter helps you identify what the real life flow is for each gallons per flush. Next. So here we're indicating a standard tool that's used by Fannie Mae and Freddie Mac, or Fannie Mae actually, and this is the actual standard 4099.H form. So in the far left-hand right, there's a calculation of how many people are on the property. So you input how many studios, how many 1 bedrooms, how many 2 bedrooms, how many 4 bedrooms there are, and you give a total from that. And then also you have the occupancy, so the percent occupancy, and then you give then it gives you an output of how many people. So using that, you fall over to the far right, upper right, where it gives you the fixture count. So this is your standard count that we talk about the EPA has. And you have below that as a standard adoption, right? So below that particular table, there's another table where you actually enter in the quantity and the rates that you identified during your survey. And then that backfills the total consumption on the far left below, and you get a standard. You have to fill in all your forms and tell what the total consumption is, and you can get a variance there. So a percentage variance of what you calculated to what the bills are, and you have to figure that out, and you change adjust your rates to figure out what your actual consumption is. Next slide. So that's water audits. We're going to a hands-on for lighting. So here we have a standard building that's back of house where you see it's in the electric meter room where you have 2 fixtures, 2 bulbs per fixture. And this particular scenario, it is T8 bulbs. They're 4-foot bulbs. And to the right, you can see what the bulb is. This is a 32-watt bulb. So very first thing you have to do in measuring the system, you got to know what your initial case existing consumption is. Next. So in here, we're showing that there's 2 fixtures, 2 bulbs, 32 watts per bulb. And then you have a ballast factor of 0.86. We're going to assume that it's running 24 hours a day, 365 days a year. Then we're going to convert it from watts to kilowatt hours. And then you have your total kilowatt hour per year consumption of 964. So here's your efficient or your EEM here. So we're going to replace them with a 15-watt bulb, but you have to bypass the ballast. So here's your proposed case. So it's going to be 2 fixtures, 2 bulbs, 15 watts this time, 24 hours a day, 365 days a year, then your conversion factor, and then you only have 525 kilowatt hours per year. So in this It's a simple calculation. You're going to end up saving 439, which is almost half of the consumption from the conversion. So here I'm showing it in an energy model. So if you put in all the inputs, so this is your existing case. If you can look at all the numbers inside there, and then your proposed case. And in this particular scenario, your savings will be the existing, subtract the proposed, and then you have, in this particular example, it'll be 11,914 kilowatt hours saved per year. So for examples on HVAC items, many equipment deteriorates over time. So we're using a reference of NRL 550 38 238 produced on May 6th. So here's a table showing how well your efficiency is based on what the case is. So you can see the column that says seldom or never maintained. So that table correlates, and you can do a calculation of what your real life consumption is based on your conditions. So here's another example of a different type of system and another. So an existing building, here's an example here. An existing building has a 2-ton system, packaged heat pump installed in 2012, which operates 2,100 hours annually. Its nameplate and SEER is 12. It is seldomly maintained. The estimated energy savings by replacing the existing packaged heat pump with a new heat pump of the capacity of SEER of 15. Here's your calculations, and that's your table. And then here we go with a base efficiency of 12 SEER with the maintenance factor of 0.03, and at the age is 10 years installed. The current efficiency would be, rather than 12, it's going to be 8.85. So your annual consumption will be, if you do all the calculations across there, it's going to be 5,695 kilowatt hours per year. Now your new heat pump will only consume about approximately 60% of that, right? So it's 3,360 kilowatts hours per year. Energy saved by replacing the existing heat pump with a higher efficiency heat pump will be a total of 2,335 kilowatt hours per year. So whenever we do the tables in the normal forms, you see that everything is calculated in a vacuum. And in this particular scenario, we're going to talk about interactive effects. So a good example would be lighting. So if it's a fluorescent light or something like that, there's heat effects with it. When you convert them over to LED, there's less heat, right? So the potential increased heating requirements can result in a significant reduction in gas energy savings, leading to difficult meeting gas goals. So here's a diagram showing that. So let's look at a few examples. Fuel savings percentage and individual measures with interactive effects. So here we are with low flow fixtures at 4%. And then we combine that with a heat pump with heat pump water heater, which would save you 15%. Well, the total should have been 19%, but if you combine them, you're actually only saving 16%. And what we do sometimes is combine them in packages. So building envelope installation at 15%. And then we combine that with a double pane windows at 23%. The total should be 38%, or is 38%. Air source heat pump combined at 39%. Combining the air source heat pump with the double pane windows should have been 62%, but you only get 49% if you combine them with interactive effects. That means that you need to create a model with all of that in together. So if you combine the air source heat pump with the building envelope installation, it should have been giving you 54%, but it only gives you 44%. Now, if you combine all three, it should have gave you 76%, but actually it's giving you 55%. So that's why we show them in packages here, to give you a realistic feel of what the total savings will be if we implement multiple EEMs. Why is this important? While adding all the measures together without taking consideration the interact effects, the site savings can sometimes exceed 100%, which is never going to be able to happen.
All right, thanks, Adam. That was that covers our main content today. I know that was kind of a quick whirlwind trip through what an energy audit is, and we covered a lot. And I see there's some questions. Before we get to your questions, we have one more poll question here that we want to pop up there. This is maybe a little bit of a quiz based on some of our introductory comments, but we're curious, based on your understanding of BEPS in terms of energy auditing, how many buildings do you think are going to need to have energy audits in DC over the next couple of years? So I'm going to launch our poll, and we'll give that a couple of minutes for you to do that. While you're answering that, just to reiterate that last point about those interactive effects, the key there is that we know how to calculate individual measures, and we need to calculate individual measures, to look at them as a standalone. But when we really start adding things up, we have to be careful not to add things together and think that we're going to get like that 50-something% savings, when because you add them together, you're getting less combined savings in effect. So I'm going to give it a couple more minutes on our poll. We've got about 2/3 of the folks have answered the poll. I want to give a few more answers to see what kind of response we have in terms of energy audit requirements looking into the next few years. All right, I'm going to give it like about 10 more seconds. So if you want to give us an answer, go ahead and click. We've got about 70% response rate so far. So I'm excited to share these answers with you and talk briefly about what we think those numbers, where we think those numbers fall currently. All right, I'm going to give it like 2 more seconds. 3, 2, 1. All right, we're going to end the poll, and I'll share our results. So, all right, so 44% of you feel like we're going to have more than 1,000 energy audits required by BEPS. The next number was 31% of you said 500 to 1,000. One person said 250 to 500. We had a couple people who said 100 to 250, and then one person said less than 100. It's certainly, none of us have a crystal ball. My estimate of where we're going to end up would probably be between, at least in the next 2 to 3 years for this first cycle of BEPS, would be between 500 and 1,000. I don't remember, maybe I didn't share that information up front like I intended to, but there's about 2,000 properties that are current BEPS applies to. And by definition, about half of them don't meet BEPS. Officially, there's about 800 that have been identified as not meeting the BEPS standard. And I don't think 100% of those will do energy audits, but I think somewhere north of 500 energy audits, maybe going back to early last year into the next, say, 12 to 24 months. So this is a really important topic for us as a city, because there's such a huge demand for this work. And we really appreciate you getting on here to learn about energy audits. Hopefully you've learned some things and are ready to, move forward with, let's see, there we go. All right, thank you. So sorry, I was trying to get to this summary slide. So to summarize real quickly, you know, again, I know we covered a lot really fast here. So the slides and the recording will be available to you. But we've talked about the basics of that first level 1 audit. I like to talk about it as a qualitative assessment. That gives us a quick look. That gives us a basis to understand how a building compares to the other buildings out there, and gets us starting with a customer to talk about how much potential there may or may not be in their property to find savings. Level 2, we're going to start doing our analysis and breaking down our costs. Really, the point here is very critical, foundational element is getting an understanding of how the building is using energy, what type of energy it's using, so we can then, as Oliver walked us through, understand where that energy is and what sort of measures might actually help move us forward in improving our energy performance. I like to think of this a bit as a funnel. So level 1 is a pretty wide funnel. We're looking at all the ideas. Level 2, we're going to start narrowing it down and doing some calculations to say which things make sense, which things will matter as we move forward with this. But we still end up with kind of a menu of choices at that end of that level 2 step. And then that would take us into that level 2 operations, where we didn't talk about that today, but that's where you really say drill into some, you know, if you're really talking about changing over a complete system, like maybe they have a boiler system today and they're looking to switch to an electrification system, there's a lot more work that you have to do to really drill in to understand what that opportunity is. So I know, again, we covered a lot of ground here, and I see some questions here. And so with that, I want to wrap up our presentation, and let's start take a look at those questions that we have in the Q&A here. So I will get us started there. So the first question we have is, does BEPS require the use of specific energy modeling software? If so, which one is required or recommended? No, BEPS does not. There's no software requirement. In fact, it doesn't, you know, I think if you look at ASHRAE 211, it requires you to take into account things like interactive effects. So some type of modeling software would be useful. But any modeling tool that, you know, kind of is a normally used tool for building energy performance would be useful. You do need to, as you're getting into this, you know, have an ability to calibrate your model to try to match what the energy use is. I don't know, Oliver or Adam, do you have anything to add to that question?
No, not at all.
Maybe just so we use a energy model that has a monthly balance method compared to an hourly energy model that we use when we do like a new building design support. The monthly energy model is appropriate in that case because our input data, like utility bills, energy use, is also on a monthly basis. So it's actually easier to use and makes more sense in the context of an energy audit. And not sure if we can share it, but we use Red Screen as a tool for our energy audits.
All right, thank you, Oliver. So our next question is, what's the relationship or difference between the BEPS score and the Energy Star score? And sorry, I wasn't clear on that. I know I ran through it quickly. So BEPS for most of our properties uses the Energy Star score as the standard, right? So the Energy Star score for a multifamily building or for an office building is the Energy Star score. And BEPS says what that standard is. So it sets it's a standard if you think about it. It's the bar you need to clear. So for an office building, it's an Energy Star score of 71. If you hit the 71 or higher, then you're going to be meet the standard and you're good to go for the time being. So they relate to it. Now, some of our buildings don't get Energy Star scores. And in that case, what the BEPS program uses is your source energy use intensity. So that's why Oliver talked about source energy use intensity. For one reason, that's important. Also, so you know, the Energy Star score is primarily based on your source energy and not your site energy. So it's accounting for that difference between source and site energy that Oliver mentioned. So with that, I'm going to segue to the next question. Oliver, maybe you could take this one. The question is, how is site energy use determined?
Yeah, be happy to do that. So site energy use is what's in your utility bills. So this is the energy that is delivered to your site through your electric meter, through your gas meter, through your steam meter, whatever meter you have on site. So this is information that we typically collect through utility bill analysis. And I go to the next question. How was it determined that space heaters make up or space heating makes up 59% of the usage. So this is really where the engineering approach comes in, where you have to do some engineering calculations that can be back of the envelope calculations, or it could be the use of a model. I give you a few examples. Like we have the total energy use, and then we really break it down. So we start with those energy use components that we can calculate or determine easily. You either have submetering, that's your best option. In most buildings, we don't have submetering, so that's usually not really an option. But you can do calculations like you have your lighting, so you count all your installed lighting power. You estimate the times of the day and days of the years, how often lights are on. That's where it's important to talk to the building engineer, to the occupants, and then it's a simple power times time multiplication, and that brings you gives you that component of the energy use breakdown. So you take that out of the electricity. You look then at your fans, at your pumps. You read the nameplates. You use the capacity of those pumps and fans, and again you multiply that by the hour of year runtime, and that gives you the energy use of that component. So you go through all the energy use categories that you identify during your walkthrough and calculate one piece after the other. For the space heating, what we typically do is we estimate the U value of the walls, the roofs, the windows, and then with a simple delta T calculation, so the U value times the delta T between inside and outside, either on a monthly or an annual basis, you can calculate the heat losses. And the heat losses through convection, then you have also infiltration and ventilation. You calculate those heat losses and the heat demand, and you add them up, and that gives you your space heat demand. And then in that case, that was the 59%. You can do the same thing for the cooling, and then you end up, or you can do a similar approach for the elevators, for the pool heating. There are equations that you can use to determine based on the temperature of the pool water, the volume of the pool, and the environmental, the surrounding temperature. So you determine your energy losses, and that determines how much you need to put in. You also account for what Adam presented, the deterioration of the efficiency of system. So all that goes into those calculations, and you calculate every energy use component individually, put them together, and in the end, you have a rest that you either over determine your energy use with those individual components, or you under determine, and that's where the calibration comes into the place. So this is a real manual approach and requires engineering calculations. In most of our energy audits, we use a software, we use an energy model, even though it's not really required until you get to a level 3 audit. But we experience it's simpler to just put that model of the building in the software and let the software do those calculations. And then you adjust in the software run times, usage times, capacities, and you calibrate your model accordingly. So that was a little bit longer explanation, but I think this is really important and very crucial. If you don't get that energy use breakdown right in your energy audit, all your subsequent calculations, like for the energy efficiency gain and your economic analyses, will be inaccurate as well.
All right, thanks, Oliver. I think that covered the next couple of questions, which was about how the consumption of the space usage was determined, as well as the space area. So that was a good overview of that, which I think is helpful to understand sort of what's involved with that. It's not necessarily simple, but it's takes some effort to get those numbers together. One thing I want to circle back to, so we're clear, for the Building Energy Performance Standard, or BEPS, the base year for that program is 2019. So it's based on 2019 benchmarking data, and it's based on a building's 2019 Energy Star score or source EUI in the case, so that we're all clear on that. Our next question asked is, does the webinar qualify for CEUs, for BPI, LEED, et cetera? We don't actually have this one sort of formally set up for that. I'm not sure if DCSU can provide sort of that credential for it. I do know you would probably be able to submit this through, I think they typically have some programs where you can submit, as a request for a particular course that may not already be set up and registered. So our next question is about, it says, regarding water audit and the BEPS score, what's the prescriptive versus performance measure? Those two things aren't necessarily totally related. So BEPS is really strictly based on your energy performance, although you do have to report water usage. That's a prerequisite to get an Energy Star score. So it is a requirement. And when we do our benchmarking verification, we have to track the water there. So there's not really a prescriptive versus a performance measure. I will say, based on our calculations, what we find is the water savings typically have a really good ROI based more on the water and the sewer cost savings versus the energy savings. But the energy savings help you with your BEPS score. So I hope that was helpful and useful there. Feel free to circle back if I didn't give you a good answer there. We still have a few more minutes to go here in terms of our scheduled time. So energy audit template, that's a really good example. So a couple of things I would highlight here. One is the ASHRAE 211 is very prescriptive in what you need to do. It doesn't necessarily give you a menu like a cookbook how to, but it clearly defines what you need. And as Adam was pointing out, that spreadsheet, which is free from ASHRAE, the ASHRAE 211 forms, they give you sort of a step-by-step process of what you need to do to get to the end to have your energy efficiency measures. And lastly, that energy audit template that I mentioned in the opening that DOE has developed with support from Pacific Northwest National Labs also kind of gives you some step-by-step walking. And finally, if Mark's on here still, there's upcoming courses that are going to go much more detailed in energy audits and give you more of a hands-on how to do energy audit type thing. I guess Adam or Mark, if you can also, if you're still there, you let us know when the Zoom might be available. Are you there, Mark? Well, we'll need to find, we'll come back to that one and see if we can get you a good answer for that from DCSU of when it's available. I believe they will probably send out emails to let people know that attended that it's available. So the next question is, what are the certifications that many of clients prefer energy auditors to have? I think there's not a huge, I would say, what I'm seeing is that list that we saw earlier, the CEM, the Building Energy Audit Professional. Those are the two that we see frequently in RFPs or when people are looking for something, because those are things that you would need to, to comply with what the city's looking for. And I think this is also, we're all in the midst of getting educated about, what's required and what's expected in terms of those certifications. I believe that as much as anything, what we're finding is clients are looking for people who can provide services that are understanding how the energy audit is helping them meet this Building Energy Performance Standard. And that means both people who are currently don't comply and people who are, looking down the road and saying, well, we know that the standard is going to require greater and greater energy efficiency, and we want to start thinking about, what we might do in the next 5 or 10 years. So I think those two I mentioned, the Building Energy Performance, BEAMP, and then the CEM are probably the top two. But the other ones are certainly valid credentials, and the city recognizes those. So the last question we have right now, unless somebody pops another one in there, is, would the lead water calculator be considered a legitimate modeling method for determining savings in an audit?
I would say yes.
So Adam says it would be. Okay, very good. All right, so I'm going to stop sharing at that point.